Hey everyone! A few days ago I posted a video working through some more challenging SAT math problems. So tonight we're going to work through some more challenging ACT math problems. And since it's the ACT, of course, you can use your calculator the whole time. So for number one, in the following figure, each circle is tangent to the other two circles, and the two shaded circles are identical to each other. What is the ratio of the shaded region to the non-shaded region? So this one's tough because they don't give us any numbers to work with at all. So we are just going to make up our own. So we can say that the radius of one of these smaller circles is 2. So that would make the area of one of the smaller circles, because we know the formula is pi r squared, so that would be pi times 2 squared, which of course would be 4 pi. Now, if that's the area of one of the shaded circles, then the area of both of the shaded circles is going to be this times 2. So that'll give us an area of 8 pi. So we'll keep this number in our heads to go back to in the end. Now we have to figure out the area of the non-shaded region of the circle. To do that, we have to get the area of the entire circle and then subtract the shaded part that we just found. So the area of the whole circle, if the radius of one of the smaller ones was 2, that means the diameter is 4, and the diameter of one of the smaller circles is the radius of the bigger circle. So that means our radius for the entire circle is going to be 4. So it's going to be 4 squared pi, which is 16 pi. But then we have to subtract the area of the shaded region that we found to get the part that's left over in the non-shaded region. So 16 pi minus 8 pi is just 8 pi. So these are the two numbers we're comparing to each other. The area of the non-shaded region to the area of the shaded region. So 8 pi to 8 pi is the same thing. So we just have a 1-to-1 ratio. For the second one, Andrea and Zach are both waiting for an appointment with a guidance counselor. When they arrived, each received a card from the secretary telling the hour and minutes of his or her arrival. 2 minutes ago, Andrea had been waiting exactly half as many minutes as Zach. 3 minutes from now, Andrea will have been waiting exactly 2/3 as long as Zach. If the time is now 11:30, at what time did Andrea arrive? So for this one, they want us to make a system of equations based off of the information that they're telling us. So for the first equation, we're going to take it from this sentence right here. So 2 minutes ago, Andrea had been waiting. So we have to represent Andrea 2 minutes ago. So that's just going to be A minus 2. So at that point, she had been waiting exactly half as many minutes as Zach 2 minutes ago. So that's going to be Z minus 2. So there's our first equation. Our next equation jumps to 3 minutes from now. So then Andrea will have been waiting 2/3 as long as Zach. So now we're doing A plus 3 because it's 3 minutes into the future. And at that point, she'll have been waiting 2/3 as long as Zach 3 minutes in the future. Okay, so now we have both of our equations. So we're going to have to use substitution or elimination to solve for both of our variables. To do that, though, first we need to make everything nice and clean and get both of our variables on one side and combine our like terms on the other side. So we're going to distribute this 1/2 to the z and to the -2. So that'll still give us a minus 2 on the left side, and then we'll have 1/2 z minus 2 times 1/2 is just 1. Then we're going to bring the z to the other side, so minus 1/2 z, and then we want to bring the -2 over to this side, so we're going to add it. That's going to give us a minus 1/2 z equals -1 plus 2 is positive 1. So there is the first equation that we're actually going to be working with. Then we're going to do the same thing with this second equation. and distribute the 2/3. So that will give us a plus 3 equals 2/3 z plus 2/3 times 3 is going to be 6/3, which will reduce to just 2. Then we want to bring the z over, so subtract that, and we want to also bring this positive 3 over by subtracting it. So that will give us a minus 2/3 z equals 2 minus 3 is -1. So that is the second equation that we want to work with. Now we're going to use probably substitution. It's just a little easier with the fractions involved. So we can take either one of these equations and set them equal to a. So if we take this first one, that'll give us a equals 1 plus 1/2 z. And now we're going to take this expression and substitute it in for that a. So down here, that is going to give us, instead of saying a, we're going to say 1 plus 1/2 z, and then minus 2/3 z equals -1. So here we just want to combine our like terms. So we have 1/2 z minus 2/3 z. And since we can use our calculator, we'll just type that in as 1/2 minus 2/3. And that is going to give us -1/6 z. And then we're also going to subtract this 1 to combine it with this -1. So that -1/6 z is going to be equal to -2. Now to get rid of this fraction and just get z by itself, we're going to multiply by the reciprocal. So that's just going to be -6 on both sides. It cancels out here, and that tells us that z equals 12. What they were asking us for, though, is what time Andrea arrived. So that means we have to go back and plug in what we found for z and solve for a. So we can take either one of the original equations and just plug in z to solve for a. So if we do the first one, that'll be a minus 1/2 times 12 equals +1. 1/2 times 12 is 6. So a minus 6 equals 1. Add the 6 to the other side, and a equals 7. So that tells us that Andrea has been waiting for 7 minutes. We know that the time now is 11:30. So if we just subtract 7 minutes from that, that tells us that she arrived at 11:23. Subscribe to our channel for more videos coming soon, and check out bettercollegeprep.com to see all of the products and services that we offer. Thanks for watching.